which was actually good. So the synthetic data was not generated. If I insert any another image and the confidence is extremely high or extremely low, then the synthetic data will be generated here. And this data will go into our retraining model, which is efficient at B0. So here during auto retraining, so here high confidence. So then the user can select a label here. And also we've deployed this actually. So all you've seen was in a deployed version. So yeah, now we're open to all questions.
Judges, do you have any questions for us?
Just a basic question. I don't see the URL. Wait, have you deployed this application?
Yeah, it was on Vercel actually. So here you can see the front end is hosted on Vercel and the back end is hosted on Hugging Face.
Got it. Okay. Thank you.
Yeah.
I'd also like to add, I think we missed why we were using both our models. So I'll talk more on that. Our baseline model was Convex small model. So it is a 50 million parameter model. And this is inspired by a vision transformer. So we could not use vision transformer mainly because we did not have that much data to train the transformer on. And because CNN on a much smaller memory or like a smaller version was available on the uh, same type of uh, same type, so we used that. And the second one was efficient at B0. So this is a very small model, 50 million parameters model, around 20 MB memory. This is getting retrained again and again so that how much ever more uh, GAN augmented images we put in the training data set in it, the more better our model gets as time goes by. And also, I would like to add, we are all market ready. And the first thing we decided to deploy it in the research institutions, IITs and ITs and BITS, any institution that has semiconductor fabs, they can use for research purposes, and we can also increase our accuracy and be better. And then, of course, we'll integrate this into semiconductor fabs, which is like already 10 startups government has funded. So we are deciding to have a SaaS enterprise model for that, and we'll just integrate into their system, existing systems.
Can you show me once that log analysis part of this particular software you have built? So how this particular segment is taking the logs, like what are the parameters of things and what it is taking?
So we have a data set. So this is the data set here. It is not a, it is a purely labeled data set. It has 6 defect categories and we've used those parameters for training our model.
Okay.
So on that basis, it creates a confidence, top predictions and everything. So the timestamp is given, the probability is given, and the interference time, drift detection, and synthetic trigger move.
So the probability is already given in this particular log system, or you are also using some external parameters that is building your own probabs?
Yeah, so that data set has 8 categorizations. We've normalized it into 6. So data is not imbalanced at all. Each defect has a equal number of images. So I guess we have 480 images here. Okay. And every category has 60 images. 60 or 80, like 6 categories are there.
And what is that synthetic data part?
So if the data can be generated, so here in the detect defect detection, there is always a room for randomness. So
Okay.
the defect can be random. So
Yes.
if it is a random, so then the data will be generated through GAN. So GAN generates like purely accurate, like near to accurate data. So then that will be used for retraining. And here, as you can, I've shown in the demo, I can select a label here. So these are the niche categories for this: the scratch, random, particle. If the user does not know what category it is, it will put in a random. So the particle and that data will be gone into the efficient net model. That is a second model for retraining.
So you have used the RAG architecture for this particular software.
Yeah.
Okay.
For explainability part, we've used drag architecture. So we've also given the references here actually. I can show you the references. Yeah, there were references here for one epoch and everything. Yeah, yeah. Yeah. Any further questions?
Judges, do you have any further questions for them? Sir, ma'am, do you have any further questions for them? Okay, so that's all from our side, guys, and all the best for your future endeavors. It was very glad to have you here. So, yeah, you can leave the meet if you don't have any further comments. Please.
Thank you. Thank you so much.
Thank
Thank
you.
you.
So, sir, ma'am, the upcoming team is the last team for us. Am I audible, Nias? Hello.
Yes, yeah.
Yeah, you are.
Thank you.
Shall we start?
Yeah, guys. So, all of your teammates are here, right?
Yeah.
Yeah.
Once again, I'll make it clear to you. If you switch on your cams, that will make this the meet interactive. Yeah. Let's go, guys. You have 5 minutes of pitching time. You will present your prototype and project, everything. We will have a small cross questioning time, and thereby, well, thank you. Thank you. You can start.
Oh, is my screen visible?
Yes, yes.
Yeah.
Imagine you are building a startup. You would have spent all your money, time, and investing in that resource. Suddenly, a malicious command attacks on your server and destroys it. These are what RCE attacks are. And to tackle that, we came up with a solution of Ajax. Yuvika, over to you.
So presenting your Ajax, our desktop tool, the homepage that you see tells you about the features that we'll be offering in Ajax. Also, it has a notification bar at the top that informs you about the webhooks that have been dispatched, the emails that have been sent, or the logs that have been exported. Now coming to the email report section, in that you can add your email, choose the format that you want to export in JSON, CSV, HTML, then choose the person you want to send the email to, and you can send the log report to that person, like you can see on the screen. And then coming to the chatbot system that we have, you can talk to this chatbot that is a cybersecurity expert. You can ask only cybersecurity related questions to this chatbot. Then coming to the threat monitor, it contains all the commands that have been run on the system, flagging them as malicious, safe, or suspicious, and the malicious commands gets killed at that moment before being executed even. Now, coming to the sandbox part, it's basically a testing ground where you can try running a command. Like, it was a malicious command, so you get a complete verdict about that command, and you can generate an LLM analysis as well about that particular command in simple plain language English. Yeah. Coming to the alert section, we have integrated a feature that's webhook URL. Now that companies mostly use Slack, so for now we have added Discord as well and Slack as well. The moment I have chosen the trigger suspicious and malicious, the moment any suspicious or malicious command gets executed on my system, I'll instantly get a ticket generated on my Slack and Discord channels about that particular command. Now coming to the yeah. Coming to the analytics section, it has all the history of the 24 hours, all the commands, all the blocked commands, then the footprint telemetry, and the heuristic distribution of the commands that have been executed. Now, coming to the settings, we have a remediation button that's basically about choosing the commands. The moment I toggle it on, the commands that are malicious instantly get killed before even getting executed. Now, coming to that, now we have session tokens as well. And scrolling below, we have AI sensitivity threshold, which is for particular companies. Companies can go from completely passive to aggressive about the commands that are being executed on the system. Over to Shashwat. That was.
Okay, thank you. Now coming on to the technical part, as she mentioned, we specify commands based on three metrics. But before that, I want to take you back to the time where I got this idea in the first place. Few months back, I was in a Pico CTF like CTF hackathon, and I had no idea about cybersecurity. So I was just solving Pico CTF challenges, and I came across a very common trap, which was eval traps. Then when I researched it, I came to know that remote code executions and eval attacks are very common in any startup or any company. So I was just researching on if there is any particular solution where these types of attacks can be tracked or can be stopped. So there was isn't. And this particular hackathon gave me a head start on to making this idea a reality. Now coming on to the testing part, for Windows and Mac OS specifically, we can't actually access the kernel for our main feature. But in Linux, we actually use eBPF native systems. What we do is we stay at the kernel level, and we actually act as a watchman, which looks for any suspicious command that is being run on the servers. And if you see a command that is flagged as malicious in our security sandwich, its process ID directly gets killed. Well, I wasn't able to exactly replicate that in Linux because I was having some technical difficulties. So I made a demo here where you can see it's keeping a track of whatever code I'm sending here. So as you can see, if I write hello, so it's getting updated at real time via WebSockets, and I get its score and its LLM generated response. Now if I flag something like a malicious command, its PID will get automatically killed. Like suppose this was a malicious command, and if I'm running it, its PID automatically gets terminated, and it is just a sec. Just a sec. It hasn't skipped. Now you may think, "Ki, why is the malicious command getting skipped?" Because it automatically detects on what device you're using. An NC based shell command doesn't actually work on Windows terminal or Windows services. It's actually a Linux command. So any Linux command which has been killed, okay, here's one with a PowerShell command which has been killed. So this is how robust our application gets. Now coming on to the sandbox, this has been again discussed by Yuvika. Now coming on to another technical challenges. There was a huge scarcity of malicious commands as nobody in the online space actually gives you those commands or gives you those data sets because nobody wants to get exploited on just because of their action. So we had a very limited data set, and to be honest, we are working on a very primitive data set which has like somewhat around 12,000 plus malicious commands and safe commands combined. So that is what our ML scorer is trained upon via logical regression.
Now coming on to the real world testing part, I have actually brought up a script which acts like a server. As you can see, I just have to paste my session code and then I can run it like a server. Suppose I want to see 10 codes at a time. So as you know, basic server, you will get multiple commands at every single second, every single fraction of time. So our backend needs to be fast enough. As you can see, I'm spawning 10 different random codes, which is getting calculated at the real time, and it is actually checking if it is safe or not. For our updates, I noticed the fact from all the feedback that you have been giving us. For particularly first we were given the point of including CVs and OSK 10 codes, which were integrated in the dataset then and there. Then we got two major feedbacks, which were a plugin system and a forensic report system, which we're actively working upon right now. And this is all from my side. This is Team Magic. Thank you.
Hey, hi, Ashwat. Hi, Shreya. Hi, Yuvika.
Hello.
Yeah.
So, you guys did a great job. So, I have a couple of questions here.
Yeah.
So, can we call it as an agent that will be incorporated to the existing tools like Slack, or what can we name this?
It's actually more of a desktop environment tool which sits at the top of your majorly server. We have built this for majorly server level tool because most of the requests or most of the requests that come from any website or any channel, it would be computed in the server only. So we're not calling it an agent. The Slack feature which I'm mentioning, it's just a ticketing system or just the advanced notification system which are using for as okay, like in a normal system, nobody would be sitting at the desk all day in a security department looking at the thread monitor. So rather than that, we have actually cut you some slack and we have actually integrated a notification channel where you can, if it is a malicious command that has been detected, you will automatically get a notification and you can generate a ticket. And the process of entire from the Department of Security to Department of Execution, we have actually bridged that gap very quickly with our notification system. So no, we won't call it as an agent, but rather than a server developer tool.
Okay, also, the follow-up question, like the ticket generation will be automated or is it should be done manually?
For now, we have only based on the notification system, the ticket system. Again, like Slack has many plugins and APIs for that. So we haven't really focused on the ticketing feature. But we have what we have done is we have built a streamline channel which just notifies the Slack.
Okay. So, for the notification section, are we incorporating any cloud or are we just using web token or webhook kind of here?
Yeah, we have actually integrated webhooks because of the WebSocket thing, things get actually very pretty fast on webhooks. So we have integrated webhooks instead.
Is there any limit for the notification generation or kind of per day, per hour
For
alerting
my
mechanism?
for my research up to my testing, I haven't seen a rate limit till yet, and I like on concurrent calls it may have a limit for which I have a solution I'll discuss further. And for right now for normal testing, we haven't hit that mark.
Okay. Okay, if I would need this as a platform to
Okay.
incorporate into my organization, so
Okay.
could you please elaborate how can we do it?
Yeah. So first, it comes under the section of a B2B model. What we'll do is we'll to communicate with a and organization thoroughly before we implement it in a server. We'll actually communicate with you on what are the actual malicious commands that you get hit with, because every command has their own confidential data sets which they have stored, which they can like very lazily calculate it. Will will communicate with you, will gain those data sets and will specifically customizably train our models so that they get more advanced and get used to your specific needs. After that, we'll incorporate our scripts or shell command that will be integrated in eBPF, because maximum of the servers that any organization use are based on eBPF system like Linux systems, to which our eBPF command will be acting on as a guard. So every request which will be sending on to your organization will first pass through our backend, and you will instantly get either a ticket or a notification if there is any malicious command that has been done on, and if it's not, the request will pass on to further middleware. So that's how we're planning on to integrating it with other businesses, particularly your organization. Will be happy to communicate.
Okay. Yeah, team. That's all from me. Yeah, all the best.
Thank you, sir. Thank you, sir.
Yeah, I have one question. So
Yes.
these issues, whatever you detect, right? Those are just the system level issues, or even at the application cloud level issues also gets identified.
Well, for now, as I said, we had a very scarcity of malicious commands. For now, we are only tackling with server level commands, which can corrupt the servers. Like you can see in my like Postman server, all the commands are like owned maliciously, and like all these commands have the potential to break a system if it is not secured enough, like importing a Python library or running a loop. Like many at times I've like read on that like a command which wasn't actually malicious at all at face, but it ran through your system continuously, hence clogging your memory, and that's how the server gets corrupted. And everyone and engineers had no idea what was actually causing it. So this is also a feature that we have integrated. So for now, we are only focusing on server level, making it fine and refined. For other fields, cloud-based, we also got a very good feedback today about transactional logs. We are definitely making sure to integrate that for integrating them in our entire backend. So for now, we are only focusing on server level malicious commands.
So these malicious commands, whatever you have given, it's a part of a kind of rules engine, right? You're defining it.
Uh, the rules engine actually processes on regular expression patterns. This doesn't have like any of the codes isn't actually hard coded. So
Okay,
in
you
every
just
common,
okay have some regex patterns within the engine what you have developed.
yeah, and we have the second layer for the machine learning model, which actually has the highest weightage.
Okay, okay, cool. Yeah, all the best.
Thank you.
So one quick question from my side. You guys have improved a lot. Just one thing that if you are implementing this in an organization, which kind of OS you are using, like what you are planning of?
Well, in my mind, when I was researching, I found that almost all the servers that are running in the entire world are Linux based.
Yes.
So what we are planning on to is to go full on to for Linux based. The Windows one, as I told you, I was having really hard technical difficulties all this time for running Linux. Even you suggested us for a VM and dual booting. Actually figured that out, but it was lagging a lot, so I wasn't able to test in that. So that's why I made an API for Windows and Mac only just to demo it. But our main source of action and source of development would be in Linux.
Okay. Good. You can just try the Proxmox for the Linux one. That is free and it is for servers.
Proxmox, okay.
That
Uh,
would
that,
be so good for the organizational developments.
mhm. Okay, noted. We'll look into it.
Yes.
And specifically, thanks to you for all the very helpful feedback that you have given in all of the rounds.
No, your tool is now a lot better. Have you worked on that specific, I said plugin
Uh,
part?
Yeah, we are working
uh,
on that. We have the implementation plan, and mostly probably very soon we'll be adding that feature as well. So we'll reach out to you once we are done with that.
Yeah, very nice. I would be surely helpful for that.
thank
Thank
you.
you, guys.
Thank you, team. Thank you for your time. Judges, do you have any further questions? Judges, do you have any further questions to them?
Nothing from my end.
So, guys,
Nothing
all
from
the
me.
best.
Yeah.
Thank you, sir.
Thank,
Thank you, ma'am. All the
thank
best
you
for
for this
these.
opportunity. Thank you.
With this, we conclude the final review. And Niaz, do you have anything to speak, please?
From the helper side, I would like to thank each and every judge who gave their valuable time. And even we got to learn a lot from your expertise. Navya ma'am, who was there last time also, this time also, it was so good to have you back with us. And really, really thank you. Shivam sir, you joined late, but it was really, really great to have you. And your expertise in cyber security is something which I am very, very I have been following so much. Shivam sir, thank you so much, and the whole Cyber CIA for being with us throughout. So then I would like to thank each and every judge, Prithviraj sir, uh, each and every judge who was there with us over the time. Really, really thank you. And we plan to conduct even more events and would like to have you back as our panel, and hopefully we stay connected. And again, thank you so much, Nayaz, also for getting us connected with all of you esteemed judges. And thank you so much from our side. And this is where we conclude the hackathon. To all the participants who has participated, I'd like to give a sincere thanks. And again, to our judges, really, really thank you for giving your valuable time. It has been like almost 4 hours till now, and you have been connected with us. It really means a lot to us. And being students, we really learn a lot from you guys. Thank you so much once again.
Thank you so much, Nabil, for having us. All the judges were the were very nice panel. It was too good to get to know a lot of things from them too. And thank you so much for having me as your judge in this particular hackathon. Thank you so much to the Nayaz and the Prithviraj, Kunasa, or Navya ma'am, or Rishabh, everyone from your side too. Thank you so much. And this, this is how I leave.
Likewise, sir. Thank you so much.
Thank you. Thanks, Nabil. Thanks, Nayaj. It was a good event. Yeah, I think even I've met Shivam today. I think Karthik, I know, but yeah, it was a good event. Hopefully, it was insightful to the participants as well. Yeah, thank you.
Thank you so much, ma'am.
Yeah, thanks team. Thanks Nayaj. Thanks Nabil, and thanks Navya for the blockchain things. I'm new to blockchain, so for with this session I learned something new. So and Shivam, everybody, thanks for having me. It was nice session. Thank you.
So, what an incredible day it has been. Congratulations to every participant. Thank you, our judges. Thank you, our mentors. Thank you to all our volunteers. And thank you to everyone who made Confluence 2.0 an unforgettable experience for us. So, with these, we can conclude our this session, this meet. And thank you to all our participants for being with us so long.
Good
Yeah,
night.
thank
Thank
you.
you so much.
Have a good day, team. Good night.
Thank you so much.
Thank you, sir.